Hello, my name is Paul Jones. I'm Conservation Manager here at Aerospace Bristol. And today I'm hoping to give you an appreciation of what goes on behind the scenes when conserving or restoring aircraft or machinery structures. So this aircraft next to me here is a Bristol Bolingbroke. It was designed in Bristol, and the British version was called a Blenheim, which you may have heard of. But this aircraft was built under license in Canada during the Second World War. And this particular airplane was first registered in 1941. And it saw active service in Canada during the Second World War, either submarine hunting or a general bomber on both the east and west coast. So this aircraft, the history of this aircraft is at the end of the Second World War, the Canadian ministry sold the aircraft to basically prairie farmers. And prairie farmers are very innovative in how they use different components. And so they saw this aircraft as a part store. And so they used all of the hydraulic jacks, the hydraulic motors, and anything that they thought would be useful, they basically took off the aircraft and used it in their agricultural daily life. So when we came to get hold of this aircraft, it had already been through about 3 different organisations that had ambition to restore it. Very little work had been done on it, and the aircraft was in a very bad condition because it had been laying in a field in Canada for probably 30 years and then moved from pillar to post from museum to museum. So this aircraft came to us in 2006, and it was donated from an expat who lived in the USA. And so since then, a dedicated band of conservators and restorers have been putting this aircraft back together. And so as we move through the aircraft, you can see that this is the cockpit. This cockpit would have originally had a pilot sat here and a navigator sat here sideways, and this was basically the perspex windows that he would have looked out to work out where their location was. And moving further back, so the conservation and restoration, the restoration we've done on this aeroplane involves most of these panels that you see that are newly painted, and these angles here we've had to manufacture from scratch. We've had to find the original fasteners to be able to put this aircraft together. And even the tubular frame that supports it, because it was so badly damaged, has had to be remade, remanufactured. But you can see it's taking shape now and it's starting to look like a cockpit. So very soon we will be joining the cockpit to the centre wing. And the centre wing also has had a massive amount of work done. When the farmers were taking the components off of these airplanes, they did it the quickest way they could. And in some cases, because they wanted the aluminium fuel tanks that were in the wing, instead of unbolting the tanks or unscrewing the panels, they basically took them off with an axe. And so some of the panels actually had holes in them with axes, which they then took the tanks out, which was the bit they wanted. So we've had to put new skins on the aircraft, on this centre wing. Again, it's using the same materials that was originally used, and also finding the rivets that were originally used. And this centre wing is now in fairly good condition, and we're getting to the point now where we've got enough confidence in this structure that very soon we're going to be able to jack this aircraft up to its normal height and support it under the wing, so that we can then start attaching the rear fuselage and the cockpit to it, and it will start to return to looking more like an aircraft. Things that we've had to do, for example, this frame here was manufactured to allow us to turn the centre wing so that we could work on both sides. Because you can imagine, if we had it in its normal plane, to work underneath is very hard work. And I mean, none of us are getting any younger in this trade, so it made it very difficult. So made a frame that we were able to rotate the wing and work on both sides, which made working life very easy. And our plan very soon is to take it off of this frame, as I said earlier, and put it onto jacks, which are onto stands, which are the same method that was used when the aircraft was originally built, get it to the correct height. That allows us to put the lower items like landing gear and even the engines on, which sit here on this particular airplane. So that would be the next stage, is to take this frame out. You'll see here, these are the original flaps, and you can see that they are now working. And so these again have had to have extensive repairs to get them to the position they are now. And we're hoping eventually to get them so that we can operate them with electric motors. Just in passing, you can see here is the pilot seat, which has been totally restored. And there's some pretty innovative methods of getting the components that we haven't got, either by 3D printing, which is an element we're looking at now, but even in some cases by just making them from wood, in a restoration sense, making them from wood. And this control column here, when you look at it, it looks like the original aluminium one. This is actually made from plywood. So you can see what can be done with a bit of care and high skill of some of the people that work on them. When we come down, this is now the rear fuselage of the aircraft, and this is would have been the gun turret. So there would be a dome, a perspex dome on here, and then there would be guns that would be looking to shoot down anyone that was attacking them. And you can imagine the life of the person that flew the airplane and sat in there for hours on end in freezing cold conditions, no heating, waiting for someone to start shooting at them so that they could shoot back. So, not the best job. Moving down, you'll see there's a few bullet holes in here. And we don't think that they were generated during action. We think this was probably while they were sat in that Canadian field that I mentioned earlier, is that people thought it would be a good idea to take pot shots at it. But we'll leave them there anyway, because it's part of the history of the airplane. And then moving further back, we come to the tailplane. We've had to do some quite major work on this tailplane. The first issue we had is that we only had one wing tip, which basically goes from there to there. So what we did is we took this one apart and we made an identical copy for the other side, the opposite hand. They're actually the same both sides, it's just it basically flips over to the other side. So when we go around the other side, you'll see there's basically a brand new one on there. But we've also had to rebuild these. These are called elevators, and they've always got a hardwood leading edge on these, as they've got a hardwood leading edge here. And then eventually these leading edges get covered with a canvas or silk material, which is then treated with a resin, and that protects the wood from the environment, basically. It makes the wood waterproof. If you look at the structure that's underneath the surface, so this would be, this is aluminium, but this would have been covered with a fabric, which again would have been treated with a resin, which makes it tight like a drum, and if you banged it, it would actually sound like a drum. Extremely light, but it gives you that aerofoil that you need to be able to control the air that's flowing over it. And underneath, you'll see that there's these are aluminium angles, and the condition of these was so bad that most of these have been made as copies. Now, if we had one on one side, we could make a copy for the other side. And in some cases, we've got limited drawings, so we've actually been able to remanufacture these to the drawing. The rudder would normally sit here. There was a major piece of structure missing here, which is under manufacture now, and one of our volunteers is working on that. It's such a complicated job that he's been working it for probably about 5 months, because normally it would be made, machined, and we're making it by hand. We're basically making it from hand skills alone. So that's why it's taken longer. Then eventually the rudder will hang in this position up here. So move around the aircraft, you can see this is the new wingtip on the tailplane that I talked about. To all intents and purposes, it's exactly the same as the other side. Once this aircraft is painted, you would not know the difference. You can see on this aircraft the original registration, 9048, and you can look up 9048 online and you will get some history of this aircraft. So a Bolingbroke 9048, it will tell you it was first registered in 1941, and some other information about where it's been during its life. So once we've got this aircraft jacked up, we can remove this wooden frame which is supporting it, and we'll then have the airplane on these stands to allow us then to start building the aircraft with landing gear wheels, as I said earlier. Now, some of the techniques and machinery that we use, there's a lot of machinery around here. Some of you may be familiar with, and some of you may not. So this, for example, is known as a fly press, and it's got nothing to do with squashing flies. Basically, this is for punching holes in material. You have a die that fits in here, and you put it up, you put your metal there on top of the die, and the weight of this ball swings it around, and you can punch out circles or any other shape out of sheet metal work. And that allows us to create this kind of effect here. If you can, I don't know if you can see this, but these are called flanged holes, and what you do is you punch out the center hole, and then you use another die which forms this radius on the top, and what that does is turns a very thin, flimsy piece of material into a very rigid but very light. In this case, it's a rib. And then moving through again, the next, this is called a guillotine, and so you would get a piece of metal like this, and if you wanted to cut a bit of metal off, and I'll cut a bit off just to show you, what you do is you slide it in there, you put your foot on, and you heard it, so basically cuts a nice clean straight line. And then moving around. So this contraption here, which is almost like a piece of art, is known as an English wheel. Now, we don't really know why it's called an English wheel, because we've got some accounts of it being used in France during medieval times to make armour, but they were made of, they had wooden wheels on, or hardwood wheels. And what this machine does is it creates shapes like this. So you can imagine if you were trying to build, say, manufacture, this is a cowl off of that aeroplane, and you can see that the shape, it's not just curved, but it's curved both ways. And so the way that would have been produced is with a machine of this sort. And by rolling it, putting it between these two rollers, and you tighten up the vice on the bottom there, when you roll backwards and forwards, effectively, because this roller is rounded and this one is flat, what it does is it stretches the top of the material more than it stretches the bottom of the material. And what the effect that does is it gives you a curve, but you can also curve it both ways. So if you're trying to make a very complicated cowl, which is what they would call it, then that's what you'd use. The similar thing would be used on, if you imagine on old cars that had the big mud guards that went over the wheel. There are some really difficult shapes, and that's the sort of machine that they would have used, and they also used them on aircraft for the same reason. Generally speaking, it's easy to understand how to use these. It takes years and years of experience to get good enough at it that you know exactly where you need to roll so that you can get the curves in the right place. It takes many years of experience. This here, very simple tool. This is designed just to fold metal. It's called a folder. You put it in against the line where you want it to fold. And if I want to make an angle, I'll put that in there, lock it down, I'll pull this up, like so. And hey presto, it's turned from a flat piece of metal, which was very flexible, to a very rigid piece of metal. That's simple. And if you look at the aircraft structures in general, they're built by using these kind of angled shapes that attach the outer skin, but give you a very light, but very rigid structure. We'll look at the Bristol Fighter now, which is First World War rather than Second World War. And although it's made of wood, the principles remain the same. You need the airplane to be light, you need it to be strong, and you need to be able to create an aerofoil so that the air is controlled to lift the airplane to fly. And if you look at this wooden airplane, so this is a Bristol Fighter, And the Bristol Fighters were built during the First World War, and they were put together here at Aerospace, what is now Aerospace Bristol, but in this particular building we're in, they were assembling these Bristol Fighters in the First World War. The structure on these is basically, you can see that it's basically glue and strips of wood, soft wood in a lot of cases, but in some cases hardwood, and it's the same effect as those aluminium angles. Instead of, though, you can't fold wood because it would break, so what you do is you glue the wood together to give you those same angles to produce that same rigid shape. And if you look at these, that's basically what these are. They're either angles or they're a T-section like that, which means that that very flimsy piece of wood all of a sudden has enough strength to support an aeroplane when given the skin of canvas on the top. And the skinning on the top is, let's say, it's canvas. They used to use silk, but there are other materials, and it's stretched across the surface of the wing. It's either sewn or glued in place at either end, and then there is a resin. When this resin is put onto the material shrinks in effect, and then that's which pulls it to make it like tight, like a drum, as I said earlier. And when it sets, you've then got quite a hard surface that is capable of, let's say, supporting the air when you've got airfoil. So in front of me is the Bristol Fighter. So this aeroplane, like I say, was built in the 50s. This one was flown by the New Zealand Air Force for many years. It spent a little bit of time as a commercial aircraft, but a very short time at the end of its life. And it was then parked up on the end of a runway in Ardmore in New Zealand, and a group of enthusiasts saw the airplane and then decided they were going to do a project to get it back to the UK. And you can see it's got these massive doors in the front. So the air crew were at the top of the, above this loading part, this luggage, this freight compartment, and it was designed to move cars or military vehicles, depending. So they were used as a commercial aircraft to take people in short journeys, like maybe from the UK to France or the Channel Islands and so on. But they could carry 4 cars, and then the passengers would sit at the back. So this airplane was not pressurized. So if you can imagine, when you fly on your holidays, you sit in the airplane and you don't really notice any difference when you're flying at an altitude. If the airplane wasn't pressurized, you would be cold, and also you could eventually run out of oxygen because the oxygen is very thin at that height. So this limited the height at which this could fly. So also it would have been cold, and it would have been quite drafty on this airplane because this big seal at the front was prone to leak because it's such a massive seal. So if I go inside, I don't know if you can see if I stand in here, I'll show you how easy. So just by winding this handle, you can see I can open these doors like so. So they would open all the way open, and then there would be a ramp here, and they would drive the cars off. They could get 4 cars the size of cars that they were in the 50s and 60s. Whether they get them on now because cars are bigger in general, I don't know. But in the back, there would be seats, and the passengers would climb out of their car and they'd go and sit in the back of this aeroplane. They'd then close these doors behind them and off they would go. So the work we're planning to do, and it's still an option. So we talked earlier about the Bolingbroke being restored. Well, sometimes, that airplane's been restored, which means that you haven't necessarily got the records of what you've done to that aeroplane since it was in operation. If you think about a Bolingbroke, it was owned by probably 3 or 4 different groups or people. It was left in the middle of a field, so we don't know what has been done to that aeroplane. We only know what we can see, and so that we would call a restoration. This aeroplane, however, was in service and then parked at the end of this runway in New Zealand. And since then, it's had virtually nothing done to it. So in the sense of, is this an example of an aircraft as it was when it was in operation? Well, it absolutely is. So we need to be careful about what work we do on this aircraft, because we could turn it from being an actual example of a flying airplane into just another airplane with no records. So this airplane, we're really lucky. We've actually got the maintenance records of what was done before it was grounded. So we know where it was. And so as long as we record everything we do on this aircraft, and we do it in accordance with the engineering manual and methods that were there originally on this airplane, then we can genuinely say that this is a genuine example of a Bristol Fighter as it was in flight.